Welcome to the next video in the GaneshaDx tutorial series. This time we're going to look at polygons. So let's go ahead and just dive right in. See that I already have GaneshaDx open, and I will open a map that you're probably pretty familiar with, which is map 56. This is the monastery. This is the first map that we played when we started our journey into the world of Final Fantasy Tactics, and unfortunately the last map that a lot of people played when quitting their journey into Final Fantasy Tactics. But not us. We pushed through. We learned to love and appreciate this game. So much so that we are now at a phase where we want to generate our own content for this game. So I figure, could there be a better fitting map for us to start that journey? I don't think so. So let's take a look. Remember from the first video that we have multiple layers for our maps. We have the background, the lighting, the terrain, and so on. The one that we're going to look at is the polygon layer. As I click this polygon tab here at the top right, you'll see that we don't have any properties for our polygons. We have some render options, which we'll talk about later, but this doesn't affect any of the actual game. When I click on a polygon, you'll see that now we have a bunch of properties. We have the positions of our vertices, the normals of our vertices, our terrain binding, and the invisibility angles. We'll definitely talk about each of these sections later in this video, but for now, just understand that these are all the properties that you can set for this polygon. As I click on different polygons, you'll see that these properties are updating and changing to reflect the selected polygon. If you hold Control, you'll see that we expand our selection, and you can also contract your selection. Holding Control will toggle any polygon in and out of your selection. But you'll notice that as I add polygons to my selection, that the properties are not updating. So what if I wanted to modify the properties of another polygon? So these properties are in relation to the first polygon that we selected. So you'll see that we click this, and as we add polygons to our selection, these are not updating. These are representative of this polygon. And that's indicated by this polygon being highlighted brighter than the other polygons. You'll see if we click this, it might be a little bit easier to see that this is highlighted brighter. This is the first polygon that we selected and is shown its properties in this panel. If you wanted a different polygon to edit, you can just click that polygon to start a new selection where it's the first, but that can be pretty time consuming, especially if you have a large selection already and you don't want to rebuild your selection. So you can hold Alt. Let me select some more polygons here. You can hold Alt and click on any polygon in your selection, and that will be the new primary polygon, in which is being represented here. And see that as I hold Alt, a different polygon is being highlighted brighter, and our properties are being updated to reflect that polygon. And if we modify our properties, you can see that only that polygon is being modified. We can also hold Z to center the camera on our selected polygons. And this comes in handy because sometimes you may be in a situation where you're looking at this polygon and you want to look at this from another side, and as you rotate it around, it's kind of, you're tilting your head back and forth, and sometimes it goes off screen. It's a real pain. So if you press Z, now no matter how you rotate this or zoom in, it will always be at the center of your screen. This is particularly useful if you are trying to modify the polygons that touch this polygon. So if this was our selection and we wanted to look at both sides of this without using Z, it's a little awkward. See that the right side is over here and now the left side is over here. You press Z and now you can easily check both sides of this polygon. The next thing that you can do is you can press the delete key to delete polygons. We don't really want to delete these. That was just for demonstration's sake, so I reload the map. And you can add new polygons to your scene through the Add Polygon window. We'll talk about that in a moment, though. So now that you know how to actually work your way around this, let's actually take a look at what polygons really are. So polygons are surfaces that are defined by 3 or 4 vertices. You have red, green, yellow, and blue. And other polygons, you only have 3 vertices, red, green, and blue. We'll go ahead and delete this. Polygons can only have 3 vertices or 4 vertices. You can never have 5 or more vertices. So keep that in mind. You only have 3 or 4. And what we do is we call polygons with 3 vertices triangles, like you would expect, and we call polygons with 4 vertices quads. These vertices do matter in the orientation that they're displayed. So we have red, green, yellow, and blue. And when these 4 vertices are displayed in a clockwise pattern, this is the direction that your polygon will face. If I rotate this behind, you'll see that this polygon doesn't have a back. You can see right through it. It's like that polygon's not even there. And this is true not only in Final Fantasy Tactics, but most game engines. Polygons only have one face. There are some games which polygons are back-sided face too, but it's not very common. And the direction of that face is defined by the order of your vertices in a clockwise pattern. If your vertices go red, green, yellow, blue in a clockwise pattern, this is the direction that your polygon will face. This isn't super important to know because normally you can just click this button here that says flip normals, and now you can see that the face is this way. But keep in mind too that our red, green, yellow, and blue are still in a clockwise pattern here, whereas from here, red, green, yellow, blue are in a counterclockwise pattern. So we'll go ahead and flip this back. While we have triangles and we have quads, we also have another type of polygon, which is an untextured polygon. Untextured polygons, as you might assume from the name, do not have textures. Textures are the pixel graphic data on our polygons, and these polygons do not have any of that. They're pure black. So that's one main difference between untextured and textured polygons. There are 2 other differences. The second difference is that untextured polygons do not receive any lighting data. So as I change my lighting, we'll change our ambient lighting to various hues. You'll see that these polygons remain pure black. They are never tinted. It may appear as though they're being tinted. That's kind of a trick of your eye. It's tinting these. If you cover the screen with everything except for these, as I move the color of our ambient lighting, they don't change. This is also true with our 3 spotlights that we looked at in the first video. You'll see that as I rotate this around our map, that different polygons are being tinted red, but none of our untextured polygons are being tinted red. The third difference is that untextured polygons will always, under all circumstances, appear on top of textured polygons. What this means is that we know that this shape here is, I think, a rhombus. I'm not entirely sure, but it's not a rectangle. We have this little shovelly part that comes out with the green vertex. When we slide it into our bridge, we see that we can't see this entire polygon anymore. We know that there is a chunk down here that is being occluded by these polygons here. However, when you save this and load it into the game, that won't be the case. This polygon will appear on top of these polygons, even though these ones are in front. No matter what, your untextured polygons will appear on top of all other polygons. Let's go ahead and delete that. We're also going to reload our map so that our lighting is back to normal. Now, another important thing to note is that these untextured polygons are best used for these cross-section pieces. So we know as players conceptually that this monastery and this terrain has not been lifted out of the world of Ivalice and placed into a void. We know that conceptually the rest of the world still exists, it's just not being displayed to us. This is good for players so that they're not, distracted by extra parts of the world that they can't get to, and it's easier on developers because we don't have to create more content that's not going to be used. And so what the designers of Final Fantasy Tactics did is that they create a cross-section, almost like you just sliced a piece of cake out of a sheet cake, right? And that cross-section is represented with these untextured polygons. This is a convention that the Tactics team had done, and it's a convention I think that you should also follow. Now, technically, you can do something where you have textured polygons on this cross section, and it'll render just fine. It'll look just fine. But there's something about doing that takes away from the original aesthetic of these maps. For the various reasons that these do not receive lighting, that they always rest on top of other polygons no matter where they're positioned, it's best to use these only as cross-section. Arguably, that's its only use case. You should only use untextured polygons to represent the cross-section of the map. It's important to understand that we have 4 types of polygons. We have untextured triangles, we have untextured quads, we have textured triangles, and textured quads. These are 4 distinct types of polygons, and each polygon type has a limit in memory. Let's take a look at our map tab here. You'll see down here under polygon counts it says untextured triangles, 27 of 64 used. Whereas untextured quads, we are using 45 of 256 untextured quads. You can never have more than this total amount. You can't have more than 768 textured quads in your scene. The engine will either crash, it'll refuse to load the map, or it will just look kind of weird. It'll be funky, right? And these 4 types of polygons are not interchangeable. You can't convert one of these into another. Once you create a triangle, it will always be a triangle. Once you create a polygon with a texture, it will always have a texture. When we go back here to add polygon, which I promised we would talk about, you'll see that we have a dialog box that asks us to add a new polygon. It asks us 2 questions. Is the polygon that we're going to add a quad, and is it going to be textured? If you uncheck both of these, you will have an untextured triangle. Here you'll have an untextured quad. This will have a textured quad, and this will have a textured triangle. With these 2 checkboxes, you can create any of these 4 types. But there is kind of an issue with this, which is that when you create your new polygon, it just kind of places it wherever, and it has all default properties. So as I click this, you'll see that our normals are pointing straight up. Our texture is snapped to the top right corner of our texture map. We'll talk about textures, of course, in the next video. We have known visibility angles. Our terrain data is default. And so if you were to use this polygon to, say, add an extension to this bridge, it'd be kind of a pain because you would have to position it over there and you'd have to line it up, and it's just very time consuming. So luckily later I will show you a much better way of adding polygons. So we have talked about the basic UI. We have talked about some of the shortcuts and tips that you can use, and we talked about what polygons are and what the different types of polygons are. So really all that's left is that we need to talk about the various properties of our polygon, and we need to talk about our widgets. So next we will just talk about the properties so that you understand. First of all, we have our position properties. You can see that we have red, green, yellow, blue vertices, and we have the A, B, C, D vertices, which all map color-coded to these. So if I change the value of the A vertice on the y-axis, you'll see that it goes up and down. And same with the yellow one, the D vertex. And we can move it along any of these axes. So one thing that you need to know is that for properties, or for our position, that this cyan pipe represents the 0, 0 position. The base of this pipe is the 0, 0 position. You can see that our yellow vertex is kind of hiding underneath of this pipe, but it's there, and its position is at 0, 0, 0. As we move the polygon up and down, it moves closer and farther away from that 0 along the y-axis. And you can see that we can even have a negative value. If I move it along the red axis, this is our x-axis, this is moving it left and right, And you can see that the x-axis is increasing and decreasing for each of the vertices, and moving it in and out of the map is our z-axis. And you can see the same effect is happening there with those properties. So let's place it right back where it belongs. Let's get it back up here. One thing that you may have also noticed is that these position points are always whole integers, meaning that the numbers are 1, 2, 3, 4, and never something like 1.68 or 2.77, whatever. If you are familiar with traditional 3D modeling in software like 3D Studio Max or Maya or Blender, you'll know that there's like an infinite space that you can work in. So you can have a vertex at position 1.778612 whatever, and there's an infinite amount of space. That is not true in the Final Fantasy Tactics engine. Everything snaps to an integer. It actually is a little bit easier to work with in the long run because you can ensure that all of your polygons match up. Again, if you're familiar with 3D software like Maya or Blender, you'll know that you normally work with one mesh that is made up of multiple polygons. That if you were to grab this polygon and move it up in Blender, that these vertices for this polygon would also go up because they're stitched together. That's not true in Final Fantasy Tactics. Every polygon is its own polygon. And every polygon has its own vertices. This blue vertice is not the same as this green vertex. I keep saying vertice, but vertices is plural and vertex is singular. So you'll see that even though when placed into position, these two vertices share the same space, they are not the same vertex like they would be in another software tool. And in this way, it's really nice that we only have to deal with whole numbers, because if this was at position 84.66 and this was at 84.64, they would look like they're in the same position, but they actually weren't, and everything gets kind of crazy. So be thankful that we're working in whole numbers. So let's take a look at our next property, which is our vertex normals. Each of these four colors are color-coded to our vertices like we saw with the position. And we have two properties for each normal. For each vertex is normal, you have the elevation and the azimuth. The elevation can go from -90, which means it's pointing straight down, to +90, meaning it's pointing straight up. You also have, if I put this to a 45-degree angle, it's azimuth, which indicates which direction it's facing, sort of like hands on a clock, where 0 degrees is at the 6 o'clock position, 180 degrees is at the noon position, and 360 wraps back around to 6 o'clock. Between these two properties, you can get this spike to point in any direction you want. Now, you may have noticed that as I do this, that we are getting some lighting issues on this polygon, and when we select off of it, you can see that the lighting kind of looks weird. It's like shaded over here. So what are these normals actually do? Well, they tell this polygon how to deal with our light. We'll definitely talk about this more in the lighting tutorial, but the main thing to understand here is that when one of these spikes is pointing directly at a light source, it will receive 100% of that light. And when one of these normals is pointing directly away from the light source or traveling in the exact same direction as the light source, it will receive none of that light. For example, we'll look over here and we'll see that these are all facing out this way. And so this light is coming from here and is not lighting these as much. And we can prove that if we go here and change the color of this light. You'll see that as we change the color of this light to green or cyan or blue, that these polygons are being tinted, but these ones are not because they're facing away from this light. Like I said, we will talk more about this in our lighting tutorial. Just wanted to make sure that you understand that that's all these spikies are. They look confusing and kind of scary, and they look a little bit in the way, but they do serve an important purpose, and that's the reason. So let's move on down to our next section, which is terrain. So remember that we've talked about how terrain is the actual part of the map that the UI and the AI understands, that polygons are entirely cosmetic and only a visual representation of the world, but not an actual physical representation of the world. Each terrain square here has a X and a Z coordinate. And as I click on these different ones, you'll see that updates 5, 6, 5, 5, 5, 4. Over here is 1, 3, and so on. Well, this one here is 3, 2. And if we take a look at the polygon that's in the same spot as that terrain, you'll see that its terrain value here is 3, 2. So what's going on here is that when you use magic spells and it highlights the ground, or it shows you the distance that you can walk and it highlights the ground, it has to know which polygon specifically to actually highlight. And because the polygon layer is entirely cosmetic, we have to inform the engine which polygons associate with which tiles. So, for example, here, we know that this has to be highlighted if a unit can walk onto this terrain tile. And so this terrain tile is 5-2, and so we simply bind it, saying that it is 5-2. That's what terrain. That's what the terrain binding does. We'll definitely talk more about this when we actually get into the terrain video, but understand that that's what this field does. Finally, we have invisibility angles. So this cyan pole represents the southwest corner. If we look at this straight down, this is southwest, meaning that this is north, this is east, this is south, and this is west. When you snap your camera to one of the game positions, like we talked about in the first video, the 4 arrow keys will snap you into the 8 different positions that the in-game camera can see. You'll see that we can only look in 4 directions. We can look northwest, northeast, southeast, and southwest. And these correlate to these down here. The 4 corners represent those exact directions. So this is, I am looking exactly northwest, and that is represented with this checkbox. And the same is true for the other 3 directions. So what exactly does this do then? This will hide this polygon from rendering if we are facing in any of these check-marked directions. So in this case, this polygon will disappear. It will be invisible. It'll appear like this. This is what you'll see when looking at that polygon from this direction. Let's let's dig down there and bring it back up. While in game, if you rotate the camera to view here, you will see the polygon again. The same is true if you're looking southeast or southwest. But when looking northwest, because this is checked, this polygon will not render. So why is this useful? Well, there's 2 reasons that this is useful. You'll notice that in some maps, this may be like inside of a dungeon, and this will be a wall. And when you look here, you can't see the wall. But along the wall, there might be like a weapon rack, holding swords and axes and whatever. And it would come out from the wall a little bit, not enough that it would stop any unit from entering this terrain tile. But it would be a little bit of fancy decoration. However, when looking at it from this angle, you might see parts of that weapon rack, but not enough of it, and it would obscure or occlude the character standing in this cell. The weapon rack would sit on top of it. And so what you might want to do in that case is select all the polygons that make up that weapon rack and tell it not to render when looking from this direction. That's what this is for. Now you'll see that we have the 4 corners that I already said will represent the in-game views when you're looking at exactly these directions. So what are the 2 on either side? The 2 on either side are for when, say, you're casting a summoning spell and the map rotates really fast. Sometimes while it's doing that, we would be getting an effect like this, where the map is rotating like that. And there are times where you're not looking Like in this perspective, you're not looking northwest exactly, and you're not looking northeast exactly. You're looking somewhere between northeast and northwest. That's where this would come into place, is if you are looking almost northwest, but not all the way northwest. Same as here, right? If you start from the southwest and then go to look towards northwest, there's a part like right here that's not quite northwest, right? And this is where this polygon would disappear. And you can, if you were to check these two, and we looked at this from the southwest angle, we would see this polygon, and as it rotated about here, it would disappear, and then when we get into this perspective, it would appear again, and then as it rotates until it gets to here, it would appear invisible. Hopefully that clears that up. It's a little confusing, but if you play around with it in game, you'll probably figure it out. The other reason that you might want to hide polygons is for performance. So if we click this polygon here, we'll see that it's hidden if you're looking at it from any of the northeast directions. This is looking at it from northeast, and as you can see, no matter what, you can't see this polygon. It's being hidden by these by the front of the church. However, it's still being rendered unless you turn this off. Now, I've noticed in my own experience that I don't notice any performance gain or loss by allowing polygons that are hiding behind other polygons to render. I haven't noticed any, but your mileage may vary. And if you're noticing that your map is running really slowly for some reason, go ahead and just go through each of these polygons and figure out from what direction they're not visible and make sure that they just can't be rendered from that direction. Here we can see it when we're looking northeast, which is why it's not unchecked. We can see this polygon when looking southeast and when looking southwest, but we can't see it at all when looking northwest, and that's why the original developers hid this polygon when looking at it northwest. So those are the main properties of our polygons. We've got one more bit to go. I know that this video is already half an hour long, but we need to actually be moving these polygons around, right? We need to shape these polygons and control them. It's not enough just to interact with them, and I mean, moving a polygon this way would be time-consuming and horrible. So, which coincidentally, the previous version of Ganesha that the community used for a long time, this was the only way, and you didn't have any click and drag stuff. You had to actually click in this box and type in your new property. It was quite a hassle. So, GaneshaDx introduces widgets. So let's talk about our 5 widgets. We have select polygons, translate polygons, rotate polygons, translate vertex, and translate edge. Each of these are bound to a hotkey, Q, W, E, R, T, and they are in order of these as they are just on your keyboard, Q, W, E, R, T. So let's talk about our first widget. We're going to talk about translate polygons first. As you click on this widget and choose an arrow axis, as you've probably seen me do a little bit in this video, you can just move this entire polygon. But there are some nice little modifiers. The first is that if you hold control while dragging it, it drags much slower. This is useful for cases like this where I'm trying to slot this into the correct spot and you can see that I'm not quite aiming. And sometimes we have problems with this. Either we have a shaky hand or a janky mouse. Either way, it can be kind of hard to do. So if you hold control, you can finesse that right into place and it becomes much easier to do so. So control will slow our selection. It'll slow our roll. The next option is Alt. If you hold Alt, it will move it in 28 by 28 increments along the X and the Z axis, and 12 increments along the Y axis. So why 28 and 12 though? Well, that's because our terrain layer, every cell in our terrain is perfectly square, and they are 28 units by 28 units in size. Additionally, if you were to increase the height of a terrain cell, it increases by exactly 12 units up and down. You can't create a terrain that is between this elevation and this elevation. When moving our polygons, if you hold Alt, it will snap according to that exact same grid. This is very useful for a lot of reasons. For example, if we wanted to move this little chunk here to be flush with here, we can hold Alt, and we, without having to aim or use Control to slow down or deal with any precision, put it exactly into place so that it maps along exactly with our terrain layer. Right? Now there's a third modifier that we can use with this widget, and that is Shift. If you hold Shift, it will not move the selection. Instead, it will create a clone of your selection and move that instead. And you can see that now, quickly and painlessly, I have extended this grassy area out to here. Right? I'm going to go ahead and delete this and show you something else that's pretty nice, which is that you saw I had a little bit of trouble lining it up with this. Not a lot, but a little bit. If you hold Shift to clone your selection, and you hold Alt to snap your selection to the grid, you'll see that we will do both at the same time. Look at how quickly and easily this works for creating this entire thing. A really nice use for this is, say, let's go ahead and delete all this mess that we've added, is say you are creating a wall. Let's go ahead and grab this, move it up, and if you wanted to create a wall along here, you can hold both of those down and quickly, easily create your wall. See how nice that is? And then using Control, we can grab these, all of these polygons, or rather using Alt, and move them up, and it is perfectly aligned and still on our grid. We didn't have to do any crazy math or calculations or eyeballing anything. It just simply snaps into place. I'm going to reload the map so that we have our polygons back. So that is the movement widget. You will be using Alt and Shift a lot as you're building out your map. They are the fastest ways to create new geometry. You'll remember that we went up here and said add polygon, how much of a pain it was to position this. That is not an ideal way to do it. However, if you're starting with kind of a blank map and you don't have any, say, untextured quads to create the rest of your level with, you will want to go here and say add polygon to create your untextured quad and position it into place, and then you can start using your clone and Shift on these polygons. That's the way to do it. So let's talk about our next widget, which is actually the previous widget, Select Polygons. This works identical to the Translate Polygon widget, except that you can't actually move anything anywhere. If you hold your mouse button, though, you can increase your selection just by drawing over these polygons. If you want to add another polygon to the selection after you've released your mouse, however, you'll see that I'll release my mouse here, and then I'll want to add these. Well, it reselects it. Very annoying. But if you hold Control, you can add just like you would want. Now this does not allow you to unselect polygons. You will have to go back to the Translate Polygons widget to unselect polygons. But this is a very fast way still to create a selection of polygons. For example, if we wanted to select the front of this church, if we were to do it with this other mode, look at how long this is taking. And then you never really know where the polygons start and end, so you have to have like a split second of recognition for where the next polygon would be. However, using the select widget, we will just go all the way up and down this, look at this side, and grab that. And that was so much easier and faster. Our next widget is Rotate widget. This one is probably the most complex of the three, but if you select a polygon, you can rotate it around an axis. Now, this might be a little bit confusing to look at. The UI for this is a little misleading, but this up arrow means that everything on the left side of this axis will move up, it will rotate up clockwise around the axis. And the same is true with the other side. It will move this side up. Hopefully that makes sense. It takes a little bit to get used to. So if I click this, which vertices would go up? That's right, these ones here. And same with this side. Doing on this axis, we'll rotate it just like that. And same is like if we do this, you can see that we are rotating this polygon here back and forth, sort of like a swivel door. You can also do this to a selection of polygons, and it will move that entire selection around the center mass, which means that if we click these here and we rotate it, you'll see that the entire thing is rotating around the center of these three axes. So what happens if you don't want to rotate it around there? Well, you have these four colored checkboxes, which are indicative of your vertices. Remember, red, green, yellow, and blue. If I click the red one, this box turned into a circle indicating that we are rotating around our red vertex. You'll see that our widget has moved to this red vertex. If we click the yellow one, it has moved to this yellow one. If you click a circle here, it will unselect and find its average point between all of the vertices that are selected. So if we do this, we'll see that we are rotating clockwise and counterclockwise around that vertex, and all of these are staying exactly in the same ratio and distance away. So if you wanted to rotate around this yellow vertex, however, we can use our all command that we talked about earlier to change the first polygon, and now we are circling around that vertex. So when we want to rotate around a vertex, it is rotating around that colored vertex of the first selected polygon, which we have already talked about. So if we wanted to rotate around this vertex here, this yellow one, we would click there and then click the yellow, and now we're rotating around that. And you can see that it's rotating. This part would be coming up, and this is going way underneath. Right? It's way down there. Okay, so that's super useful to know. There's another thing that's super useful to know, which is we are going to grab these polygons here, and I'm going to clone them and move them up and out of space. And you'll see that I'll use my plus key. This is a good example for using the plus key, which is that all of these polygons are disconnected from the rest of the scene. So no matter how much I press the plus key, it will only select these polygons and it'll stop there. This is very useful for selecting an entire set. So let's turn this off. No matter how many times we rotate this, we will never have the shape where this is over here. We would need to mirror our shape for that to be the case. Luckily, we can do that. If you hold Shift and click on one of these arrows on the axis, it will flip and mirror your selection along that axis. So here we will flip it this way. You can see that we are flipping it just like that. The same is true with this. We will be flipping it this way. And if you choose it on the green one, it will flip it upside down. So that's mirroring. That comes in handy quite a bit. For example, if we have this dock here, we can extend it out like this and mirror it along this edge. And now look, we have created sort of a horseshoe shape for our dock. And we can quickly and efficiently build out the rest of this dock by using our other tools. We can delete these since they won't be seen. Right? And we can take these polygons here, move them over here, use our flip normals button to give them here. And using the tools that I've shown you already, the mirror tool, the plus tool, whoops, it turns out that these polygons are actually touching over there. We've gotten a little too close, so I will just use the select polygon tool and grab all of these and move it over, right? And you'll see how quickly and easily I built this whole geometry out using just a few polygons that we had grabbed from earlier in this map. That is the power of using our widgets. You could have done all of the same stuff using add polygon and clone selection and all of that stuff, but we did this very quickly using our widgets. So let's talk about our next two widgets. Our final two widgets are translate vertex and translate edge, and they're very similar. So translate vertex means that we are going to modify only one vertex. We use this to shape all of our geometry. For example, if we wanted this to be a ramp, we can do like this, and we have a ramp. What's really nice about this widget for vertices is that it follows all of the exact same conventions as the translate polygon. So if I hold Alt, we are snapping to the grid. Do you see that? If we hold Control, it moves slower. So it's not really a new widget. It operates exactly the same as the widget that we already looked at. The only difference is that it only works on the vertex. And the same is true with the edge. We can move this as much as we want, and we can also snap it to the grid, and we can use Control. Also, with both of these widgets, if you hold Shift, it will create a clone of our polygon, but that clone will only be modified by the edge or the vertex that you are modifying. So you'll see that our original stayed there. Doing that, I have so far not found a use case for it where it's actually very useful. Maybe you will. You'll notice also that we have different edges. So what if I want this edge? All you have to do is click along that edge on the polygon and it will select that edge. The same is true with our translate vertex. If you click on the polygon near the vertex, it will select that. If you select off the polygon, well, it's like any other selection option. You are selecting off the polygon. So make sure you're clicking on the polygon. Now, also, you don't have to click actually on the vertex. In fact, that often misses, like here, oops, I kind of got close, but not close enough. You just have to click near it. Now, occasionally, you'll find polygons like this one where the math Ganesha just doesn't figure out the math for whatever reason. We're trying to click near here and it thinks that we're still clicking this near that polygon. The same is true with the edge. Like it thinks that this is closest to this edge. It's sometimes, especially on triangles, it just has a hard time. You can also see that when I click here, it's selecting the opposite, these two vertices that are opposite from each other, because we're technically closer to this edge than we are to this edge down here. And so sometimes it can be a little challenging that, you know, there's no region that you can click where this is the closest edge. Either this edge is closest, or this edge is closest, or this edge. Very annoying. But you don't have to worry about that, because if you press the F key in either of these, you will cycle through the selected thing. So let's start with the vertex. You'll see that as I press the F key, that it cycles through these vertices, and if I hold Shift F, it will cycle backwards through those. Forwards, backwards. And the same is true with edges. It will start from red to green, then go to green to yellow, yellow to blue, blue to red, red to yellow. It'll do the cross section of this, and then it'll do the opposite cross section and then start over. And then if you hold Shift F, it will do it backwards. Generally, you'll be fine if you are just clicking these two edges, but sometimes you need to use the F key to cycle through. Like here, it's fine. Sometimes you don't even want to click over there, so I want to get that up, and then I'll press F, and now I get that up. It saved me a click, right? And then we'll just put that back down. Okay, so those are all of the widgets. The only thing left that I want to talk about is I want to talk about some general tips. I know that this video has already gone on for way too long, but hopefully this is comprehensive enough without being overbearingly comprehensive. Okay, so you'll see here that each of these polygons has its own vertices, and you'll see that this vertice and this vertice are overlap. However, this polygon does not have a vertice, a shared vertice here. What happens more often than not, and this doesn't happen all of the time, but it happens very often, where if you have a vertex that is touching an edge of another polygon, like in this case, you will have some rendering issues. What will happen is that the in-game engine is trying to interpolate what the line from this green to this yellow vertex would look like. And it uses some mathematical formula to figure out how this would look like represented in pixels on your screen. Well, it's also going to do the same for this edge and the same for this edge. The problem is that for each of these three edges, this edge on this polygon and the two edges on these two polygons, it may interpret those differently for each of those three edges. And what will happen is that you will see through the level for maybe 2 or 3 pixels here. It happens particularly on larger polygons. If this polygon was like this, ignore the texture on this just for this demonstration. We're going to move this up here. You can see how we have this vertex is shared along this edge. It seems to happen more often the longer these edges are, the more problems that you're going to get. So if we ran this in-game, we would likely see a huge seam where we would see through the level and see the background, or just see whatever's behind it, which actually is the background. You might even see some pixels from this dock, depending on where the camera's positioned. It'll almost appear like this sometimes, and that's not good. We want to avoid that as much as possible. So the rule of thumb here is to avoid situations like this. You don't want any vertex touching any edge. Like I said, sometimes it's fine, but other times it's not. It seems like it's fine in this case. I've never noticed a breaking seam on this map in game. That won't always be the case. And so you'll want to do something like this, where you, instead of having one whole polygon for this, we will do something like this. And now we'll see that we have these polygons all have a shared vertex right there. This will ensure that no matter what, we won't see a break or a seam between polygons. So keep that in mind while you are designing your levels. You want to avoid. And in fact, if we look through most of this level, we'll see that it's very rare that we have any vertices touching edges. They have built their topography of their map specifically so that every vertex touches another vertex. There is no vertice touching an edge. So keep that in mind. The other thing is that you may have noticed when we are doing some of these tests here that when we move this out, what we have done is if we lift this up now, let's go ahead and lift this up. Well, we have some polygons in here that will never be seen because they're hiding under. So if you do something like this, get in here, delete these polygons. The player is never going to see them, and it will only affect performance in extreme cases. And most importantly, you're going to run into issues where your polygon counts are getting too inflated because you have a bunch of hidden polygons hiding underneath of stuff. So now there's nothing under there. There doesn't need to be anything under there. The camera's never going to go inside that block. So keep that in mind. Finally, I want to talk about polygon size. If you have polygons that are too big, the rendering starts getting really bad. So there's a reason that this is chunked up like this. If we were to delete all of these and then grab this edge and bring it all the way up, well, why wouldn't that work? Aside from, you know, the vertex issue that we just talked about, but theoretically we could create a topography for this entire building that's made out of these very tall slats. But what happens for some reason in tactics in the engine is that polygons that are too big will have a tendency to render on top of polygons that are in front of it. So not that this case would ever happen, but imagine that the camera is like this. This polygon will likely render in front of all of these polygons because it's so large and it goes so far down. I'm not entirely sure what math the Final Fantasy Tactics engine uses to figure out what order polygons should render. That tends to break that math, this scenario. Alternatively, let's go ahead and reload our map. Alternatively, polygons that are too small will also have a problem. So if we had a polygon like this, and we move this down, and we took this edge, you'll see that I have a tendency to use the F key. If we have a polygon that's like this big, sitting in front of this polygon here, what will happen a lot of times is that this polygon in back will render on top of this polygon, and you won't even see this polygon. Same as if you have two polygons like this that are close to each other, and maybe this one is a different palette. Let's just change its palette. You have something like this where you're trying to create this effect. A lot of times this polygon in back will render in front of the other. So there's a lot of weird cases like that that you pretty much just have to learn and test over and over. Maybe this will work just fine in game, but also probably it won't. So you'll want to save it often. You want to save your maps often and import them into the Final Fantasy Tactics engine and actually take a look at how it's reacting. All kinds of goofy stuff happens with polygons. But generally, if you stick to polygons about this size, no bigger than this, no smaller than this really, unless you have specific reason, generally you'll be pretty okay. And then if you do want to get more detailed, make these polygons smaller for whatever reason, you'll have to go through that process of saving, importing it, modifying, importing it, until it actually looks like you want it to look like. So that covers polygons, plus a few tips, plus little gotchas that you got to watch out for, and hopefully I haven't put you into a coma yet, 55 minutes into this video. Thank you so much for following along with this tutorial, and I really can't wait to see what kind of maps you come up with. I'll see you in the next tutorial.